running. So yeah, internet is back up now. So I was talking about the hub, and now I'm going to move forward. Switch we discussed, it's a smart device, and we have Cisco is the company who, or Juniper is another company or the competitor of. Router is the hardware device that connects to the LAN with an internet connection. It is used to receive and analyze and forward the incoming packets to another network. So we can see that diagram as well. So I have some very comprehensive lecture from another course which I can share with you guys to give you the inside knowledge of these. I will post those if I need. So I have more than enough information available on this topics because this is totally a networking course which I also teach. So I have information from the networking book which I can present to you. So you will have that information as well. A router is a hardware device that which connect to a LAN and internet with an internet connection. It is used to receive, analyze, and forward the incoming packets to another network. So if one network wants to connect to another network, switch will not work in that way. You will need to have a router in between both of the networks. So sending router and the receiving router, and then once the request is made, the second router from this other network will send the request back to the router on your network, and then your network reroutes to the. So we will see a comprehensive diagram of that in when we'll go to the networking topology and how the packets get sent out and how you receive the packet back. Modem is just a device that allows the computer to connect the internet to the internet over the existing telephone lines, or you can have it on your coaxial cable. Major components of the device networking, we have these major cablings that are available, and this is just a very surface level information, but you will have twisted pair cables, coaxial cable, and fiber optic cables. Each look very different. So if you can just, if I can just quickly bring the picture here over, and I can add more details to it. So I will say types of networking topology cables. And here you go. You go to the images section as usual. You will see all different types of cables here. If you look at this picture, it is showing you a summary of, you might have seen this cable, which is in the form of, which is called UTP cable as well, which is in the form of Cat5, Cat5e, Cat6, Cat6e, Cat7 or 8 is also in the market. So these are different. And then we have distinctions in each. So as you can see some of the cables will be low quality ones, which does not have shield in them, because each of these cable will have, if you look at this diagram closely, each of these cable is kind of right now merged with another cable, but this can cause a lot of noise of data between the cables. So the more you are able to, you might be asking why we have that many shields, because there is an interference of the signal that can distort the signal of communication. The more you are able to minimize that with this aluminum foil that you're looking at, it is going to bring the noise of the signal down. Okay, and that's a fairly common in networking, that the signal strength goes down as you move away from or as your l- uh, as your cable goes big, you will have hindrances. So to keep the quality of the signal, you will have those shielded cables as well. So types of the different cables, coming back to it, you will see this is just most commonly one, and then we have coaxial cable. So let's look at the coaxial cable, and it's called coax. Sometimes you will see that again. They could have just left it without this shield. As you see in this picture, you don't have any shield, but here you have a shield here as well. The more you put the shield, the more you are avoiding the disturbances and the noise that is going to hinder the data. So these are separate chapters on the networking. How to what is the purpose of each? How much is the capacity? Um, how each of those cable perform in different situations. Fiber optic cabling, and this is for fiber optic transmissions as well. Types of networking, I just went over that very quickly yesterday. I know we have gone over peer-to-peer and client server, not just in this course, but in the previous course as well. So I will scroll over here. Some advantages and disadvantages. So the topic that I want to start today, which I wanted to go over 10 minutes earlier than that because of the internet disruption, but we can quickly catch up here. Local area network. What is local area network? Personal area network, metropolitan area network, and WAN. Let me see if I have more documentation available to it so I can share with you guys in a moment. This is my lecture notes that I can share with you guys as well. Define and describe the LAN, and mention that the LANs are usually contained in a small space such as office or building. So when we talk about LANs, usually they are confined in an office or a building. So you might have one office in which you have done the networking. So that is usually called as LAN. So there is no hard and fast rule made that this is our LAN or this is, but in general, we are talking about general discussion that this is how the LANs are. We know what is a switch, and we know what is a star topology. I showed you yesterday the star topology diagram as well, and I'm going to show you star topology diagram as well. Network topology diagrams. We need to have a sample, but that's okay. Here you go. Let's bring it up. Let's open up a little bit more so then we can look at it. Fully connected network. Each computer is connected to another computer with a dedicated cable or whatever the dedicated mean that we are connecting it to. So it's a fully connected network, which is not an ideal that you, for whatever number of nodes that you have. So 1, 2, 3, 4, 5, 6, 6 nodes. You have six connection coming out of at least 5 connections coming out of each of them. So 1, 2, 3, 4, and 5. And if I pick up another one, I will have the same. It's called a fully connected network. It's also called, it's almost very same as MASH, as you see. Again, MASH is like you have the connection like this, but you don't have a connection like this. But as you're seeing, at least connected with one or more with the cable, leaving only one behind. So this is a MASH network. The more you make connectivity, the more cabling you have to done. As you are seeing right now in the diagram, you are able to see that much how many cabling is being done. But this is the star topology. Remember, there was a server sitting in between yesterday. This is probably the most common client server architecture that we have. In here, there's a switch sitting, but we can have a server, and we know switches are so so big these days that they are the server of their own. They have the computer built into them inside their own because they are smart devices. And remember one thing that I mentioned about switch, that switches have routing tables with which they know that, let's look at this. If this computer know that I need to connect, uh, um, if I need to connect to this computer, it will be going directly from the routing table, and then this computer will let it connect automatically because this address get cached into its memory. And next time the communication happen, it will not be a burden to reestablish the connection. It automatically knows that there's a device like this that I have already seen with this address, with this hardware location. So hardware to hardware connection is pretty fast. Common bus topology. Bus topology, look at this. It's a one backbone is going through the entire network. But in this situation, what is in the star topology network, if the central device goes down, the whole network goes down, because the network main device that was guiding the whole traffic is not there anymore. In this situation, in common bus topology, if there is a cable breakage happen between here, let's say, so at least these three computers will be able to see each other because the cable break is here. And same way, if there is a cable breakage happens here, these three computers will be able to see each other because the cable is broken here in the middle. So in bus topology, the whole network does not go down. Only the communication breaks between those. So if the communication breakage happen, I will not be able to communicate with any of these three computers if the communication breakage happens here. But I will be able to continue to work with these three guys, with three guys in common, that the connection is still established with the backbone. So if you have the diagram in mind, you will be able to know what is the advantage and disadvantage of each of them. More cabling. Mesh means, again, more cabling. This is not as practical as I think, but this usually is also referred to as a mesh. Fully connected network is also a mesh kind of architecture. So cabling is very cumbersome in this one because we don't need to run multiple cables from one computer to another. We just need one cable to keep it clean. So the most common one is the star, but the problem with the star was that if server goes down, everything goes down. So it's better to have two men in the middle that are two servers. One is the backup server and the other one is a highly available server. But Azure has taken care of that. We don't have to worry about that. This is just a previous technology, just one step behind cloud that we used to have in the networking. So it's very because not everyone is on the cloud at the moment. These networking technology topologies is still out there, and we do these kind of networking at our home. If I have more than 3 or 4 computers, if I want to set up my lab at my home, I can do this way. With the bus topology, if cable breaks in the middle, they will be continue to operate until the point where the cable is broken. Those segments will be separated out. They will continue to operate. But keep in mind, if this is the internet backbone and if the internet is coming out from this side, these will still have the facility of the internet. The cable breakage happens or something happens in the middle, these guys will still be able to communicate, but because the cable break has happened, the internet disruption will disrupt only these guys because the disruption has happened at this point. These guys will continue to enjoy the internet availability if the internet is available. These guys will be able to communicate with each other, but keep in mind, if there is a server sitting here, they will not be able to communicate or authenticate these three computers. So let me take the picture of this. And if I'll take a picture of this diagram, so I can take it to explain with a little bit of, yeah. So let's say if the cable break happens here, these computers will be able to communicate with each other. These computers will still be able to communicate with each other. That's one point. The other point is if the cloud or the internet is here. So let's see if the internet is coming out from this direction. This is, I will just say, I'm not going to mention, but if the internet is here, I'll just mention it with I. The internet I is going here, the cable disruption happens. These guys will continue to enjoy. But because the cable disruption has happened in this section, these guys will suffer because they are not able to. The other thing, that the other disadvantage is that in this situation, if the server is also sitting here, so let me just expand it up a little bit, and let's say, I'll say internet and server. This is our internet and server. These guys will continue to enjoy all the facilities, but these guys, which I'm going to make a circle again, will not be able to get, first of all, will not be getting any authentication because the server is sitting here. The server machine is sitting here. Who they go to get authentication? Authentication means where they will get their credentials verified. If somebody is trying to enter the username and password, where they usually go to the server to get my username and password. But because the internet is disrupted, they will not get, number one, they will not get the internet. They will not get authenticated through the server. They will not be able to store their information which they want to store on the server. They are a small separate network of their own until that internet service revive back again. So that is the bus topology that we are looking at. In the ring one, just put a break here. Let's put a break here. What happens? This computer now still knows this computer. This computer still knows this computer. This computer can still communicate with this computer. This computer can still communicate with this computer. But now this computer will not be able to communicate with this computer because the internet disruption has happened at this point. So these are different types of network topologies. Most common one is star and bus. The other ones is ring. So if I need to send the data, if this is the computer number 1 and this is the computer number 4, if I need to send out the information from this computer to this computer, it has to pass through all these computers to get hit here. See that? If I need to send out the information from this computer to this computer, it does not need to go on to this computer as long as it does not need to send it to this computer, because if they want to communicate each other, these two guys want to communicate each other, it will send the data on the backbone. It will send the data onto the backbone. It will send the data onto the backbone, and then backbone, it will travel on the backbone, and then it will find the destination. It will receive its data. But here the problem is it has to pass through all of these computers to get it done. So that's why I say there has to be a rhyme or reason for all the different network topologies wherever it suits best. Currently in the market, in the client server architecture, these two are the ones that are prevalent. The other ones are there in terms of theoretical. They can be practically implemented, but not as much as we think. And the communication, as I told you, in the ring network, it happens like that. So these are different types of network topologies. You will hear this a lot when I will go further, and then there is a other model that we can look into. So, so I have compared the star topology with the mesh topology, where each device connects to the multiple devices. I don't have the figure, but I showed you the figure right now. Do you guys know what is network interface card? NIC. It is called network interface card.
I think we learned it in the past, but I just forgot what it is.
Okay, so network interface card is the hardware card with which it's built onto the motherboard, with which you connect that Ethernet cable. When you push in the Ethernet cable and it makes that sound, click, and you have the connection and you have the light start to blink, that card or that slot is called Ethernet card. Okay, so if somebody says network interface card, it is an Ethernet adapter where you plug in your Ethernet cable. Personal area network. We all make personal area network at our houses. When we connect, and we don't even notice, when we connect our Bluetooth headset with our laptop, we are actually creating a personal area network. When we when we are swapping our card entering into the building, we take our card and we use the infrared technology to swipe our card, and it will let us enter. We communicate two devices together. That's a personal area network. The very best example is the Bluetooth headset or Bluetooth devices that you connect temporarily. NFC, you might have heard of, is another personal area network. So all those personal area network, that's why it is called personal area network, because you are just doing it for the personal reasons. You are not distributing that. Sometimes I don't know whether I should call it a personal area network, but sometimes I pick up my phone, and from my phone I try to share my internet that is coming from Rogers or whatever my service provider, Fido or whatever. If I want to share and my internet is not working, I usually think about that when my internet stops working and I have a class going on. I usually think that how should I be able to communicate with my students? Well, at that time, if my internet is currently down from, let's say, my internet service providers, Telus or Shaw, and my internet stops working, and even after rebooting my modem or my router, I still not be able to connect for 10-15 minutes, then I need to communicate with my students somehow. Maybe I should take it into consideration and let you guys know that then what I will do, I will tether the internet connection that is coming from Shaw, and I will temporarily make this as a router. And then I will start to broadcast signals from this device, and my laptop or my desktop will be able to see that there's another new Wi-Fi that this mobile device is broadcasting. I will connect it with that, which is called personal hotspot. I want to know how many of you guys know about this personal hotspot. You might have created at one point or not.
Yeah, like when you create a hotspot with your phone.
Yes. Yes. So personal hotspot. You are actually creating a personal area network. Personal hotspotting means you tether the internet connection from the service provider, not from your internet service provider, but from your carrier who's providing you your Bell service provider or your other service providers, which are providing you the internet connection. You tether the internet from there and then you connect. So you totally disregard your Telus and Shaw internet connection temporarily, because for whatever reason, if their internet service is down, I will be able to go there. And the other thing is usually there's something called down detector shop. So if you just say if something goes down, I usually go here and say check out the problems with the Shaw internet. And these are some of the the these could be some of the actual comments when the actual Shaw service was down. Usually you go on down detector and look for the service that is currently down. As it reports, sometimes people have their own issues having out there at their um, personal laptop or computer, and they think it's probably Shaw or Thales is giving them the grief. But at the moment, you can see user reports indicates no current problem at Thales. But when it will go down, you will see the disruption like that, which I showed you, something like that, something with these kind of graph showing you that yeah, somebody reported it. It may or may not be the most accurate, but the more spikes you see, the more reliable is the data. The more less you go, it might be just somebody just out of panic just looked at that they have tried everything out on their site, but internet still didn't work, so that's why they have problem. And that's why you see after 9 a.m. when people start to work from home, they start to see a lot more uh, complaints about that. It may not be the most accurate complaints, but you see as the day starts, usually at 6 a.m., not a lot of people working. But as the day progresses, people start to make more complaints that my service is down, but it could be potentially their own problem. And you see when the people more commented, and this time I can believe that it might be at that day they have some uh, actual disruption happen, right? And remember the day when Rogers went down last year, or Shaw has internet issues. Usually, this will be the website you will be visiting constantly when the service starts to resume. I remember when Skip the Dishes went down, people were claiming for all their credit cards payment because they have made the payment but they haven't received the phone, so they have to do some compensation, and every company has to do that compensation and has to communicate. Usually you cannot hide these kind of things. You have to actually make it public that why this disruption happens, and have to make a claim for it. Coming back to the topic, metropolitan area network usually goes across two cities or two towns. That is called metropolitan area network. So as you go along, if I have a ABM College branch in Red Deer and I want to connect with the ABM College branch in Calgary, that is typically called as metropolitan area network. But what you want is not just like an internet connection to get onto D2L. That's not metropolitan area network. Actually setting up a network here and setting up an isolated network there. Those two networks, when they will be able to communicate through each other through satellite or whatever the other means of communication is, I don't think so antenna or radio will be the best option in this case, but you can communicate two devices together. I have done communication with something called, I'm going to show you some devices as I am talking here. Unify. These are some of the Unify nano stations. These are the two devices. You can connect two nano stations together. So the way I did a communication one time, I'm going to mention you that because I have worked in the as a eye of a network engineer as well, because he was not on site. So I was trying to help him out over there. So in this situation, I placed the nano station on one tower on one building, and I placed the nano station on another tower. And then if one nano station has the internet connection and the other doesn't have it, let's say this one doesn't have it and this nano station has it, it will start to broadcast, it will start to transmit the internet signal to this nano station, and this nano station, when it receives, it will give the it will give this, it will pass it on. So I'm just looking for a best diagram if I can for that. Yeah, as you can see, it is mounted, let's say, on the roof. This is mounted on the roof on one side. It has the Ethernet cable going on, and then there's another one who is waiting for it, and then there's an Ethernet cable. He can take it down. Both will be, so the way I do it, I test it first in a small room between them. If I will lay the first one up and lay the other one up, and I will try to connect with this device onto my laptop, and I'll try to connect another laptop or a small device with this one, and then okay. So the only problem with these devices is that it has to have a clear line of sight. There should not be any tree in between, or there should not be any building in between. There have to be a clear line of sight. So where I was doing it, I have a clear line of sight, and I was amazed that they can communicate with each other even if they are 5 kilometers apart, as long as they are able to see each other. So it should not be like this, that one is facing in this direction and the other one is facing this direction. No, as long as you know that they will be facing each other, usually 5 kilometers is just a little bit overkill. But if they are 1 kilometer apart, you will be able to see. And once you are able to align them, you will get good signal strength between them even. So this is nanostation solution for connecting to a single network using 2 nanostations. And you don't need to dig a hole, and you don't need to run your tractors to make the cable run down from one station to another station. Ease of life. You can just use these 2 nanostations facing each other and just do the cabling like this. And once they are able to face each other, you will have a communication. It's only sometimes in the bad weather we find them not as good. Maybe they have improved the technology. Obviously, it was evolving at that time when I was doing it 4 or 5 years ago. They have new versions, as I see, M5 or M2 or whatever their new versions have, but ideology is the same. When wide area network, usually this is our internet, because we are not talking about cities, we are talking about mostly outside of the box, like say connecting one network with another network. A wide area network is a network that extends over large geographical areas, not just cities, but states or the countries. And the wide area network is quite bigger network than the LAN and MAN. Okay, and PAN is obviously the smallest one, I would say. Wide area network is not limited to a single location, but it spans over large geographical areas through a telephone line, fiber optic, or satellite links. So not all the time your MAN will work or your nano stations will not work. You will still have to have wide area network working. And last point here that was discussed, that how should we be able to answer. So yeah, you should be able to answer now. I still think that you will be able to answer it yesterday, but let's start with this. Find 5 popular companies that manufacture the networking components. So can you name a few? One is Cisco. Second one is Juniper. And it's very easy. I should not be handpicking with you. Cisco, Juniper. I usually type first versus, and it will start. Google starts to give me a little bit of idea. Versus Arista. Palo Alto is one that I heard a lot. Versus, and you can just put more versus and it will give you the name. So Palo Alto has devices, Juniper has devices. I don't think so Unify is as a big competitor as this. Ubiquity is not a big competitor as Cisco and Juniper. Cisco and Juniper are the pioneers and giants of networking. Okay, so name a few. 5, 3 or 5 will work for me. Next question. Also write 3 lines about them, paste the link and the price. So this is your work to do. I have explained you what each of them does, what are the purpose of cabling, what is the purpose. So go through each slide, and when you will be done with the lecture today, I will ask you to do that, and please send it over to me, not by email. I'm going to create a discussion forum, and there you can post your file. So I will not lose that, because I don't want to be searching in the emails who send me what at what date and time. So I will create a discussion forum, and there you can submit and post your, or you can create. I will create the assignment section as well. You can post it there. I will create that one for you after this class. You will be able to access it. If you want to choose between peer-to-peer and client-server architecture, which architecture you will choose and explain why. So you have to look at the diagram, because I explained you the diagram. What is the peer-to-peer communication? It starts to get complicated, and it's not practical to use peer-to-peer networking. Instead, you need client-server architecture. What is the biggest advantage of the client-server architecture is that you have a central server which is authenticating and doing the communication and helping you communicate with one computer to another computer on the network. With the peer-to-peer, there is no central computer, there is no domain controller. Remember that domain controller class which I took you in Microsoft Azure. There is no domain controller. Domain controller means you become the part of the client. You become, as a client, you want to become the part of the server, and want to be a part of the governance of that server. That is why it is better than peer-to-peer. In peer-to-peer, you are just a standalone individual standing in a group of computers which have no server, and you're just trying to communicate with one computer to another, and it starts to get really complicated. Any questions on that? So these slides are actually available to you. I'm moving on to the next lecture, and I have more comprehensive slides of these. Maybe I will post it for you if you want. I will post these PowerPoint slides for you, so you will have it. But I can share it with you guys. Chapter 9 is done. Chapter 10. So I will show you a little bit of practical example. I have a program in Java that I will want to send a message from a server, and I want to send a message to the client, and the client will send the message to the server receives it, and then server will send a message back to the client, and client will receive it. So, but there's programs for it, and it is called, those programs are networking programs. So you can create a chat program where two individuals can chat over the network if they are on the same network and all that. Let's come on to networking models. This is the networking model that I'm learning since I'm the student. OSI model. So it means it's not going anywhere. In cloud, it may be pictured differently, but in general, this is an OSI model that you will hear a lot in networking. And then the second model is called TCP/IP network. It is a little different than that. We will see when we'll cover that. Network model and its layered architecture. Basic elements of layered architecture. Why do we need layered architecture? So this is a theoretical background or abstraction of networking. Basically, we have, over the years, we have identified, for any communication to have, we need to have a physical layer. meaning that we need to have physical computers. We have to have cable, we have to have a router, we have to have switches, we have to have hub or the server. These are all the physical components of our network. Then there are some other components. The networking devices are the part of the network. So let's start with this topic. Service. What is a service? It is a set of action that provides layer to the higher layer. But first, let me bring up the diagram. I don't want to go to architecture of IoT. I want to first go into the architecture of here, OSI model. So first of all, the physical layer. Data or transmit raw bits of streams over the physical medium. It is called as physical layer. Data link layer defines the format of the data on the network. Network layer decides the physical path the data will take on the network. So each layer has certain responsibility. Transport layer transmits the data using transmission protocol using TCP and UDP. There are two most common protocols. So we will need to understand what is protocol first. And then session layer. So remember, when you leave your computer and you have your D2L logged in, what happens if you leave it for a couple of hours and you come back and it says your session is about to expire? When you come back, your session gets disconnected until you reconnect back to it. So not that when you just log in, you can leave it forever and come back after 4 days and you will still find everything working. The session is made so that the spot that you have left and you are not using, somebody else can take that spot in place of you. Yeah, if you are ready to come and join, that's fine. You can enter your credentials again, submit login button, and you can rejoin back. But you can free off some sessions as well. Presentation layer is meaning that the data always travels in 1 and 0 format, right? But data gets encrypted as well. Remember when they say, I know most of you guys use WhatsApp or applications like that. It says that your data is end-to-end encrypted, right? They claim that your data is end-to-end encrypted. I don't buy that, but I'm going to just say that. End-to-end encrypted meaning that when you send a message to your friend on WhatsApp, WhatsApp encrypts that data so that nobody else in between can intervene and take your data and see what you have tried to send your data to your friend. Whether it will be a hello message or it will be a file that you are sending or a video or a picture that you are sending to your friend on WhatsApp at least. So in presentation layer, what they do is they encrypt the data, and when it hits the network layer, when it is being in the transportation, so the session gets established and then it gets transmitted with some kind of protocol. It gets some kind of a data packet attached to it, and then it will be attached to the network, and then the network will take it from one network. It goes and hit some, so it gets out of your internet, and then it gets hit the tower of your network. Then it hits the tower of your other friend, which you are trying to send it. And then let's say if he is not using Wi-Fi at home, he's traveling and he sees it on the bus. He is not connected with any internet, but then the tower from his internet service provider or from his carrier sends the data to his WhatsApp, so you can see it on your phone. So all these things has to happen. So what is WhatsApp? It's an application layer, right? WhatsApp is the application. Your browser, your Google Chrome is your application. Your Firefox is an application on which you are browsing, right? If you are using Microsoft Word on Office 365, it is an application. Your presentation layer ensures the data is in the usable format and it is and is where data encryption occurs. So your data is not corrupted, your data is taken as a full, but it will be sent out to your destination in form of packets. Who will do that? Presentation will take out the data, encrypts the data, and then it establishes the session with your friend when you send it out, until if it doesn't find that your friend hasn't registered for WhatsApp, it will not be able to register the session for you. And then the transport means the data is ready to be transferred, but there will be certain protocols needed to be added in front of your data so it is more secure. And then your network layer will establish whether it's a Wi-Fi, whether it's a whether it will be a Ethernet cable, what kind of network you are trying to choose. And the data link layer is the data format of the data. So let's look at that in the diagram. If I can share with you the diagram, if I find that diagram really quickly in my slides. So give me a break here. I will see if I can. I'm not taking a full break here. I'm just going to look at so I'm going to change. I will going to find a better representation of this so you will be able to understand. Okay, just give me a moment if I'll be able to find the better slide. And I'm going to share if I find that with you guys, because I have this topic from the networking book. I have to just this one. Here you go. Actually, I will share this thing with you. Here you go. So let me put it in my notes. I have to do a couple of things with you guys. So I will put, so I don't forget after the class. So I will put that assignment from the previous, and then I will share this mod 1 from the other book just for further explanation of things. So these are called 7 layers of OSI model. You saw that, which you
Can I ask a question?
yeah, absolutely.
Yeah. So when should we hand in the assignment after class? You said.
Yeah. When I will be done with this, I will let you guys go, and that time you can start working on it.
Sorry, I mean,
But it is
when is it due?
yeah, today, because it's not a lengthy one. It's not a lengthy one. It's just 5-6 questions, which I already explained. I'm not asking for a lengthy answers for that. Couple of lines, so we may be done within 15-20 minutes if you are fast enough to learn, understand everything. Any questions on that?
No, thank you.
Yeah. All right. This is the 7 layers of OSI model. This is the first slide of it. Usually, think of it this picture first. If I need to send out a letter to my mom, usually what infrastructure I need? I have to prepare the letter, and I will go through this Canada Post Office. I go and drop that, which is my operating system. So at each level, think of it what is happening. So your browser is running on top of operating system. So your browser sends the data to the operating system, which is Windows. your operating system has the infrastructure. You will give it to your hardware, which is network interface card, NIC, right? That is where the cable is plugged in. Or if you are on the Wi-Fi, that is your hardware. Then it will go out on the internet. This is the internet backbone. And then it finds it. Oh, here it is. So it will find that in the destination country or destination province or destination state, it finds the Canada Post Office. That Canada Post Office receives it through its hardware. And there's a hardware, always the data is traveling anyways on the hardware, whether it's a cable or a fiber optic cable running under the sea or wherever your server is. Just like in Azure, your server could be located anywhere in the world, right? And then you say you will receive it, and somebody will receive it at the hardware at their center or operating system. Their operating system should be secure, first of all, virus free and everything like that. And then you will be able to, or somebody will be able to receive your packet which you send, and then she will receive the packet and will be able to open it and see that. So you send a request to someone, and then that server replies you back as well, right? So then at that situation, that web server will be replying back to you, and you will be receiving the packet back in the really opposite direction, but to the same destination. So this is how the cabling and other network terminology works. But we only see the abstract form of it. This is but in general, this is the ideology behind of the networking, that when we browse something on the internet, our browsers gives it to the operating system, our operating system gives it to our hardware takes it to the internet, the receiving hardware receives it, that this request is for me, it must be running on the operating system, and that operating system will have the web server installed on it, and that web server can reply back. So if you are trying to reach Google, this is how it happens. But this is an abstract idea. A browser communicate by the way this is how it happens. This is not how it is fully elaborated in your diagram which you saw in your slides. Now what happens is that you have an application like a browser, your WhatsApp message example that I said, your email client, your Outlook is the application. We all use our application. We all use our browser. This happens at the application layer. At the application layer, these three layers work together. What they do is they find out what kind of request it is. Whether it's an email request, so it will be using SMTP or POP protocol. These are protocols specifically designed or coded for email services. This HTTP and HTTPS, HTTP is getting obsolete. HTTPS or Hypertext Transfer Protocol. It is called Hypertext Transfer Protocol Secure. This protocol is used by the browser. File Transferring Protocol, FTP or FTPS, File Transfer Protocol Secure. With this protocol, you can transfer the file from one source to another source on the internet. What happens at these levels? What happens? You have an application, then you have a presentation layer. What presentation layer decides is that which kind of traffic it is, whether it's a browser traffic, whether it's a email traffic, whether it's a file transferring traffic. And then it says, okay, to which destination it is intended for. So it identifies that I need to establish that session. And let's say that session is established successfully. If you want to approach to Google, that session will be established between your computer and the Google. The session is established. That communications happen, and obviously it immediately get disconnected. You immediately get disconnected. It will not just keep yourself connected with the Google session, because Google does not have to serve you. It has to handle numerous number of sessions, right? So you will get disconnected. But your session gets established. As soon as you send a message to your friend on WhatsApp, your friend receives it, the session gets disconnected. It does not need to be established anymore. As soon as he writes back, obviously from his end, the session gets established. So TCP and UDP protocols, what they do is that's where this data, it starts to get on the operating system layer, and operating system now knows that I need to transfer it using transmission control protocol or user datagram protocol. So you need to understand what those protocols are, but I'm not going to go into the detail. And then once it gets hit at the network layer, it needs to know what is going to establish, whether what are the things that I need to know. The source IP address, the destination IP address. You need to have so that you can transfer that where the information is coming for and where it is intended for. So you need to know the IP addresses, physical IP addresses of those, public IP addresses for those. And the last one, data link layer and physical layer, meaning that you are talking in terms of hardware. So the hardware will take the information. Remember, see, if you see this really closely, there's an Ethernet punch cable where it goes, and this is where the Ethernet communication happens. It happens either on this physical cable, or it will be a Wi-Fi communication that is happening. So this is a comprehensive diagram of how the communication is happening. So let's go over really quickly on each layer. Application layer, and I will share these slides with you. So I'm going to share these slides with you, but let's quickly go over. The application layer describes the interface between the two applications on a separate computers. Application layer protocols are used by the program that fall into two categories: provide service to the user, such as browser and web browser. Just keep it to that level. Don't go too much deep inside. Just think of it one example, that how communication is example. What is application? Application means your browser. You need to install the application to make a communication. You need to install the app on your phone to make a communication. Payload is the important part, where at each stage of the communication, the payload gets increased. We will see that. Presentation layer is the responsible for reformatting, compressing, and encrypting the data in a way that receiver's application can read. So it is not that you want to encrypt your packet or your hello message that you are sending to your friend. You encrypted it, but if it is not getting decrypted at the receiving end, then your friend will possibly receive the garbage, because he does not understand what the computer language is. Because once you encrypt the data, it becomes undeteriorated for somebody gets access to their data. Even if somebody gets access to your data while it's in the transit, they will not be able to understand what is happening. And this typically happens when you do your banking transaction. Your application layer, you enter your username and password for the banking, but when you are communicating with the banking, it is getting secured and encrypted. And then once it gets to that layer, it will not be able, nobody will be able to get information of that. And they have made it more and more secure. You receive OTP and all those different text and authenticator apps. Session layer describes how the data between the application is synced and recovered if the message don't arrive intact at the receiving application. Meaning that if for some reason your session gets disrupted, you have submitted your username and password, but you click submit, and at that same time your internet goes down. You actually sent the packet already, but your bank website did not receive it or partially received it. Then it might say that, sorry, I did not get the full information, or unrecognized, right? So the data, so at that time, it will either accept or reject. Usually when the session is established, it will be waiting for every part of the data. Remember, your data, when you send out the request to the banking website, it goes in packets. It does not go all in once. the whole stream of packet goes in different packets, and at the receiving end it combines all of those packets together to make it a complete full packet, and then it receives. But if it is, if you are sending the transmission, you establish the session but the data did not get transferred properly, it will not entertain that. The application presentation layers are intertwined because they are connected. It is often difficult to distinguish between them. Yeah, at what stage what is happening. Transmission control protocol, and I will not go into the details of this, but think of it that this is where your data that you click when you hit the submit button is getting disintegrated and getting secured, and will have. So let's say if you have a shipment for Walmart coming up, it might be coming up in 5 different trucks, right? So you might be waiting for, okay, so I have a store in Red Deer and the shipment is coming from the Calgary warehouse. I know I will receive at one point to make a complete shipment that I'm expecting that by the end of today, I will have this as a complete shipment. What happens is that one truck comes in, might not have my desired, but part of my data is there. I might have received 5 breads that I'm waiting to shelf, and my other 20 breads will come in another truck, right? So this is, but they all have to follow the same protocol. If the ice cream is coming, it has to stay in that truck's freezer section. It can, or if the meat is coming, it cannot be left in the unfreeze portion of that truck. So there is a protocol that has to be followed. This is called transmission control protocol. I'm not going to make that same protocol mingle with the protocol that I'm mentioning with the example of the Walmart truck. But what I'm saying, it has to follow a certain procedure, certain safety procedure. It cannot be just shipped out, oh, just cram into the truck and we'll see when it will go on the and hit the highway. It has to follow certain procedure and certain protocol. That protocol, these are the 2 different types of protocol, TCP and UDP. So doesn't really matter in which packet your data arrives, it has to arrive with a certain protocol, certain safety procedures, certain procedures have to be followed. Not just safety procedures, obviously, but certain procedures has to be followed. Protocols add control information in the area at the beginning of the payload, which is called header. So I will show you at the end of this story, I will show you a little bit of diagram that how actually the data is get disintegrated, and how what is this header is, and what is this other terminologies that they are mentioning. So I'm going over the surface because I don't want to be you to be a network engineers at the end of this class, and I cannot make you a network engineer in 2 weeks course, but I want to give you as much knowledge as you can for networking. Network layer. The network layer is responsible for moving messages from one node to the other node. So the session is established. Now the movement process will start to happen. At which time and juncture, you know what the truck that is moving on the highway will come to you. You may have a ballpark timer figure of that, right? So it's same with the network. Your sequence of packets will come together at this destination in some particular way. There could not be that one packet will come before and the other will come afterward. The packet that they have when they start to be sent out to the server or to the desired destination will go in the sequence and will mingle over the destination in the same sequence. So the data will start to make sense, because when the receiving end combines the data, it should start to make sense over there that yes, this is how it was get disintegrated. Now this is how it will get combined together. The things happen so fast electronically that we think that, oh, it is so fast that we don't even consider that, but it is actually happening in the in this way when we are sending out the data. And who is responsible for? Browser is responsible for. Operating system, for which we pay for to Microsoft and Microsoft and Mac OS and Linux. These are all the operating system vendors, and they have these technologies built into their operating system, that how they will send out this packet and how the receiver will entertain those packets at their end, even if they are different operating systems. Data link layer, media access control or MAC address. Every phone or every device that you purchase has a MAC address. So when you send out the data, it knows from where this information is coming from which physical device this information is coming from. So if somebody has to track you down, or somebody has to track the criminal down, or somebody has to track the hacker down, they will not only have their IP address, but they will also have their physical address from which physical device this is happening. So if you look at this diagram, this physical device that is attached to your computer is actually the culprit that will make you identify if a hacker or somebody is doing malfunctioning. So the data link layer contains the information about your physical drive, about your physical address, not just your IP address, but your actual physical address where this is getting broadcasted. So there's a lot of ways that you can be tracked from this physical address, where this physical address belongs to this area. Where does this physical address was sold? We can track that one out. So let's say if I go and grab an Ethernet adapter from Best Buy, they can track it down that where this physical address was placed when it was first shipped out of the warehouse and where it was sold, probably around in their locality. So then they will be able to confirm that with an IP address from which you are doing the hacking. They will gonna know that yes, this physical address with this IP address telling me that it is coming out of Red Deer area or Calgary area, whichever area is. Then they will be able to track and confirm that down, yes, that this physical hardware. So every physical hardware that you purchase has a physical address, and when you attach it into the internet, it gives you a physical IP address as well, physical public facing IP address as well. So in general, this is an important one as well, but let's come back to that. So in general, you wanted to send some information out, which is called payload. At each step of the payload, certain information gets attached to it. So it has a header and has a termination or terminator or trailer. When you send it out over the internet, all of it gets stored. Where is the starting address of the payload that you want, and where is the ending address of your payload that you want, so that if you are sending 5 different payloads, all of these 5 different payloads will get accumulated at the switch level. And then the switch level is called data layer, data link or physical layer. Then it comes out, goes out of your router, go on to the network layer, which again contains the physical combination of network, data, and physical layer, and then it travels over the internet. And then once it gets received at the physical end of the server, it all starts to disintegrate, and then the server will be able to identify where this packet is coming from, and obviously then it will send it back in the same direction that you are seeing. And this is how the packets get each packet gets disintegrated and then get collected as well. But it looks so quick to us because it's an electronic signal in forms of ones and zeros. Any questions so far? So I will upload these slides for you because this is not as explained in detail is in your slides. So let me go to- So networking model, IoT has a different networking model. We'll cover that in a moment. TCP/OSI model we have covered.